Assalamu alaikum. Welcome to lecture number 17 of CSE305 Software Requirements Engineering. And in today's lecture, we are going to discuss our topic elaboration and negotiation process. Elaboration we concluded yesterday, and because it spanned 2 and 3 lectures, so in fact more than 3 lectures. So what I would what I would do in today's lecture is that I would summarize the elaboration process, and we will try to just recap what were the some rule of thumbs that we should, as a requirement analyst, keep in our mind when we are doing analysis of the elicited requirements. Then after that, we are going to discuss negotiation process. We'll start discussing negotiation, and we will continue this discussion into our following lecture as well. In our last lecture, we talked about the structured approach for analyzing requirements or for elaborating requirements. And as we have already discussed that in the structured approach, there is only one kind of modeling that we do, and that is flow-oriented modeling. Within flow-oriented modeling, there are 3 possible diagrams or 3 possible tools or techniques that can be used. The first one is data flow diagrams, the second is control flow diagrams, and the third one is processing narratives. Now, just quickly looking back at them, that what is the DFD? As the name suggests, data flow diagram. So we are actually trying to model the flow of data through our system. And we talked about that there are multiple levels of DFD. We start with a context or level 0 DFD in which we model our whole system as a single process, and we just try to identify the inputs and output from our system, and who is going to send this input. There would be some external entities, and the output would also be targeted towards some external entities. And who are external entities? Anything which is outside the scope of our system, that is an external entity who is communicating with the system. It can be a person, it can be another system, it can be a machine or any other hardware. Then another important principle when we are making DFDs is decomposition. And as we said, we start with a level 0 DFD, we go down to level 1, level 2, level 3, level 4, and so on, depending on the complexity of the problem at hand. There was an important discussion that we had, that when to start decomposing a process further. And as I said, there are no hard and fast rules. Normally, some people suggest that as a general rule of thumb, what you do is that you try to look at a process, and if there are more than 8 inflows and outflows going out of that particular process, you say, okay, I'm going to decompose that process because this process is doing too much, and I need to actually go in and look inside that how this process is actually taking care of all these inputs and how it is producing all these outputs. But as we saw in our previous example, the example which we discussed during our lectures on data flow diagrams, that we even decomposed a process which had 5 inflows and outflows. So it depends on the problem, and it depends on the complexity of the process, and because at times the process is critical and you want to know what's happening inside. For example, in our example, there was a process the name monitor sensors. Now that process was very key to the functioning of the whole safe home product. So we said, okay, we want to go inside and actually see that how we are going to monitor sensors. Okay, so there is generally no rule of thumb, but we decompose a DFD into multiple levels, and level 1 of a DFD is interesting in a way that at level 1 we can, in a level 1 DFD, we can have all the concepts that can be drawn in a data flow diagram. For example, we have external entities, we have processes, we have data flows, and we can also have data stores. There is an important discussion that we had about data stores, that you should only include a data store if it's relevant to that level. For example, if we are drawing level 1 and there are processes there who are going to talk to this data store. For example, in our example, there was a process which was changing the configuration data, and we need to store that configuration data in a data store, so we represented our data store at level 1. But if there is a data store which is only relevant, or which would be relevant to a level 2 process, then we should not be drawing that data store at level 1. This is just to keep your diagram simple, and so that your hierarchies, they actually make some sense. Then there are certain rules of making DFDs. For example, we talked about that we number our processes in a DFD. Obviously, we don't need to number a process at level 0 because we only have one process. But at level 1, we start numbering our processes. So we number them as 1, 2, 3, 4, 5, 6, and so on. And another thing we talked about with this numbering is that these numbering are just to identify these processes. They do not signify the order of execution of these processes. And this numbering would continue to level 2, level 3, and level 4. For example, if we want to decompose process number 2 to a level 2 DFD, we will say, and there are 3 sub-processes in that level 2. We will number them as 2.1, 2.2 and 2.3. So numbering is important. Numbering actually helps us in relating that, this process belongs to this parent process and this parent process belongs to another maybe parent process. So we can actually look at the hierarchy and try to visualize because it gives a logical view, and this logical view can be taken as it is by the developers as well, and we want to describe it to the client as well. So this numbering is important so that we can actually relate, because we as an analyst, we might know what we have drawn, but other people, they should who has not actually drawn this particular diagram, they need to refer to different diagrams. So it's important that we number them so that they can actually figure out that what are the sub processes of maybe a parent process. Then another important rule when we are making a DFDs is balancing. And balancing is really important. And what do we mean by balancing? For example, there are 2 inputs coming into a level 0 DFD, and there was 1 output going from this level 0 DFD. So there were total 2 inflows and 1 outflow. When we decompose this to a level 1 DFD, we should draw a system boundary which actually shows that, okay, that was my level 0 and I have decomposed into multiple sub-processes. Now the number of inputs and outputs going out from this level 1 DFD, it should be the same. So it should have 2 inflows and 1 outflow. So balancing is also very important. We have talked about numbering. So that was DFD. But as an analyst, I have been emphasizing on this, that as a requirement analyst, I want to know more about the information domain, I want to know more about behavior, and I want to know more about the functionality of the product, and that's why we have this elaboration process within this requirement engineering process. And we've talked about there are 2 main approaches of requirement engineering. One we talked about object-oriented, and the other one is this structured approach. So we have seen that how object-oriented can be used to actually gather all these 3 things: information domain, behavior and functionality. Now when we use this structured analysis, it is important for us to visualize that how we are going to actually get this information. So when we try to identify different external entities, and when we try to identify different inputs and outputs from those entities, we are actually trying to figure out the information domain. We are also trying to figure out what is the functionality that we need in order to receive that input from the client, or receive that input from an external system or from external machine, or what kind of functionality do we need to give that output to the client. And by doing so, when we decompose it into further processes, we try to understand the behavior of the system. Because whenever an input is going to come into my system is going to behave in a certain fashion, and that behavior is decided by these processes or these operations that I identify when I decompose my DFD into further levels. Then another interesting diagram that we talked about is control flow diagram, and as we have said that DFDs are revolved around these processes, and we have these data which are being transformed by these processes. And at times there are some critical functions in a particular software. For example, in the case of our safe home product, we talked about a critical function that was safe home security function, and everything was revolving around it. So what we did was we tried to identify different control inputs and how my system is going to behave when those control inputs occur. So for example, we said there are multiple states of my system. For example, it can be in the resetting state, it can be in the idle state, it can be in monitoring state, and it can be in acting on alarm state. If I reset my device and if the resetting goes fine, then I will go to the idle state, and when I activate my device, I will go to the monitoring state. And whenever there is, for example, there is an input on a sensor which senses that the smoke levels are too high, then maybe I would go to the acting on alarm state. So control flow diagrams, they're interesting to understand the behavior of a particular function which is of importance to a particular product that we or the problem at hand. Then finally, we also talked about processing narratives. In fact, I think we got, maybe we should have talked about it earlier as well, even before DFDs, because they are really useful in identifying entities, in identifying different data that is going to flow through a system, and it also in identifying different operations or processes that are central to this whole structured analysis. So processing narratives is similar to the grammatical parts that we talked about, that we go through the elicited requirements or the user stories or scenarios that we gather during elicitation, and we try to parse them in a fashion that they help us in identifying, okay, what are the entities who is going to interact with my system, how this interaction is going to be, what kind of inputs would be sent when somebody is going to interact with the system, and how my system is going to behave, how my system is going to react to those inputs, and how my system is going to behave to produce certain kind of outputs. So that is what we talked about in structured analysis. Now, in today's lecture, as I already briefed you guys on it, that we are going to summarize our whole elaboration process, and quickly we are going to talk about different kind of modeling techniques that we have covered, different approaches that we have talked about, and then we are going to move our discussion to the negotiation process. Okay, so it is important for us to know that where in requirement engineering this elaboration process lies, and we have seen that diagram multiple times now. So for example, we have seen this particular diagram where we say that we start with inception, then we move to elicitation, then we come to elaboration. So if we talk about requirement engineering process, and in terms of the timing of the project, then where does this particular stage lies, then we can actually say that, you know, if this is the time, then we can say that our elaboration, it's it lies here, it actually starts here. It starts with elicitation. When elicitation is actually going on, we start elaborating those requirements at the same time. So we know that elaboration or analysis actually starts during elicitation, and as I said earlier as well, when we were discussing these processes as tasks in our earlier lectures, we also talked about it, that they are not sequential. So it's not happening that, you know, we finish the whole inception and then we move to elicitation. So they are actually occurring in parallel. So this is not the case, they are occurring in parallel, and same is the case with elaboration and elicitation. And the next question is, why do we need elaboration? And we have already emphasized on it, but just to give you guys, just so that, you know, we actually know where we are, I thought these questions are really important, that why do we do it? We know that elicitation is a process involving lots of humans. So you know, we as a requirement analyst, I am somebody who is going to elicit requirements from the client. So it involves people. And believe me, whenever people are involved, it's always problematical, because, you know, I have to talk to multiple people. Multiple people might have multiple viewpoints about the system, and all these people might use different ways to express, you know, the same functionality. So in the end, you know, whatever I elicit, it gets very confusing. And as I said, that this data that I get out of elicitation, the user stories, the scenarios, the interviews, the questionnaires, and the results of the surveys, they can be very confusing. They can be very confusing, and the output of this elicitation process is let's say this is very raw data. So we do not have the requirements in a fashion that we actually desire, which we can actually give directly to the developers, and they can just start developing the or which we can give to the designer. They can start designing the product, and then it can be forwarded to the developers. So it's not in a state which is ready for development yet. So what we try to do is we say, okay, we need to clarify certain things, because, you know, there might be multiple people involved in elicitation, and we always elicit requirements in natural language processing. For example, we'll either write we will write requirements, or we'll express those user stories and scenarios in English, maybe, or maybe in Urdu, or in any other language, in depending on which country you are operating in. So it is because of the people involvement, and because of involvement of multiple stakeholders, and because of multiple viewpoints that we get from different stakeholders about the same functionality, the requirements that we get, those requirements, they can be ambiguous, those requirements can be incomplete, they can be inconsistent. And this is a recipe of product failure, because if we go ahead with these sort of requirements and we start designing and developing the product, then this is a recipe of disaster, because we did not actually thoroughly understand the requirements, and the end result would be that I have lots of ambiguous, lots of incomplete, and lots of inconsistent requirements. And that's why we say, okay, now hold on a minute, we need to actually analyze the requirements, we need to actually elaborate what we gathered. So that is why we need this elaboration process. And what we do in it, we have seen that there are multiple ways of doing this elaboration or conducting this elaboration process or doing analysis. And there are two main approaches or two broad categories of analysis. One is the object-oriented way of analyzing requirements. The other is structured way of analyzing requirements. And within that object-oriented analysis, we have seen that there are multiple modeling techniques, and similarly within the structured approach, we have multiple techniques. So the next question becomes how we do it, and we have talked about that there are different modeling techniques like scenario-based modeling, like class modeling, like behavioral modeling, and flow-oriented modeling. And within those modeling techniques, there are lots of different diagrams and lot of different tools that we can use to actually perform this analysis. But as an analyst, remember that there are three key things that we are interested in. We are interested in knowing more about information domain. We want to understand behavior of the system, and we want to know more about the functionality of the product that we have to deliver. So let's quickly see, try to figure out that, how we do it. We have to, so let's quickly look back and see what kind of modeling techniques we have discussed in different approaches and what kind of diagrams we have talked about. So the first thing that we talked about within this object-oriented approach of analysis was a scenario-based modeling. And within scenario-based modeling, we said that the first thing that we can do is make these use cases. So use cases, as we have talked about earlier during elicitation as well, that they are a very useful way of actually understanding the system from user's point of view. So one thing that is important with this scenario-based modeling is that this actually gives us the user's perspective of the system. So we try to understand about the functionality, about the behavior of the product from the user's perspective, because user is the key to this scenario-based modeling, and is centered around the users of the system or the actors of the system. When we make a use case, there are a few things which we require. For example, we need to identify that who is going to interact with my system. Okay, because as I said, it revolves around this. So we need to identify who is going to interact with my system, and this particular concept in a use case diagram, it's called an actor. And we have talked about that who is an actor. Actor can be a person, it can be a system, it can be another machine. And anything outside the boundary of my system, that is an actor. Okay. And in a use case, there will always be a primary actor, and then there will be a secondary actor. Primary actor is somebody who actually initiates this particular scenario. For example, let's say we draw this use case of the ATM machine, and what we are trying to say here, that this is a client or the bank user, and so our actor is the bank user, and what he is trying to do is he's trying to so let's say how he is trying to interact with the system. So this actor, what he is trying to do, out of multiple interactions that you can do as a user with an ATM machine, you are trying to withdraw cash. Okay. So when somebody goes and try to withdraw cash as a primary actor, then machine is actually sitting idle there, and so the primary actor needs to be somebody who goes and actually start punching in the machine, or inserts his card to do a transaction. But there is always a secondary actor in this particular scenario. And who is the secondary actor? The secondary actor is the banking system, because whenever the user is going to punch in the PIN number, that needs to be verified with the banking system. Similarly, whenever the user says that my account type is current or savings, then we need to go and talk to the banking system whether this guy has pressed this button incorrectly or whether he is right. Similarly, when you want to withdraw cash or inquire about your balance, you need to go and check with the banking system. So whatever the transaction you are trying to do in an ATM, there will always be a secondary actor, that is the banking system. And so in this particular scenario, this is the primary actor, and this is the secondary actor. But imagine that when we are doing it, we are actually understanding about the system. So for example, in a scenario, somebody said that okay, this is the ATM machine that you have to design, and one of the functionality that we desire is that whenever a client comes in, he is able to withdraw cash. Okay, so maybe that was a scenario that you elicited during your by using one of the elicitation techniques. And now when you actually start making this use case diagram, we have actually started looking at it more deeply. We say, okay, So there is an actor involved, which is the guy which we've identified through that written scenario, that somebody is going to, a client is going to come to the ATM machine and he is going to try to withdraw cash. But the scenario didn't say anything about any secondary user. But we will say, okay, no, wait. When we actually try to do that, there needs to be somebody who needs to actually, do all these things. And another thing that we identified when here is that a user or a client cannot come to an ATM machine and straight away withdraw cash. He needs to do something first, and he needs to do multiple things here first. And we talked about this, that there are a couple of other notations that we can use. For example, there is include interaction that can be between two use cases, and we talked about that why we use include, because at times there is some functionality which is being repeatedly used by multiple use cases. So we can put it in one use case and say, okay, because this is common to multiple use cases, so we combine it and put it in one. For example, the authentication, and let's say the card checking and all those things, this is basically being handled by this use case. So we've talked about that include can also be used, and so from a simple scenario, now we are actually thinking about the system. Okay, that there's this functionality that we have to give, which is of withdrawing cash, but when we do that, there is a secondary actor. Similarly, there are other things which need to be done when somebody is going to do a transaction. For example, we have to make sure that the card is inserted in a proper fashion. We have to make sure that the PIN number is correct. We have to make sure that that the machine actually gives an option of selecting an appropriate language for the user, and all these kind of things. So as first step, when we start doing the scenario based modeling and we are making a use case diagram, we have actually thought more about the scenario than we had at the elicitation stage. So we are increasing our understanding of the product from the user's interaction point of view. So the next thing that we talked about within this use case modeling was use case text. And we emphasized a lot on the importance of writing use case text, because we said that when we make a use case diagram, then use case diagram usually only shows the normal behavior of the system, or it just shows that how the user is going to interact, and it does not actually completely explain the complexity of a certain interaction of a user. So for example, when we withdraw cash, now as a normal scenario, what a user would do, a user would come to the machine, so your user would insert his ATM card. So that is the first normal flow that he is going to do. Then a user is going to enter the PIN number, okay, or the first thing a user might do, the first thing is enter a PIN number. And upon entering the PIN number, the next interaction would be that the machine would prompt to select an appropriate language, for example, either English or Urdu, as in the case of Pakistan. And similarly, then the next thing that the machine would ask is, please enter your account type, and it would be current, savings, or other. And depending on your account type, then a menu would appear, and then you can select your appropriate transaction, and then you can enter amount. For example, if you are withdrawing cash, then you will enter amount, then you press OK, and then you will wait for the machine to respond. And if whenever the cash is out, there will be a message on the machine saying that please take your cash, and printing your receipt, and all these kind of things. And so this is how the normal flow is going to occur. But use case text is not just about the normal flow. When we are writing these use case texts, so what we do is that we talked about that when we are writing use case text, there are multiple sections in it. So it can be written in a tabular form, and there are multiple sections. So we have maybe use case ID. We also have some preconditions. We write about some post conditions, that what would happen, and remember that these use cases, they are drawn or they are made from those scenarios. And if you remember the discussion of scenarios which we had in the elicitation process, then we said that each scenario begins with an initial condition, then there is a normal flow of events in a scenario, and when the scenario ends, the system state might be different from its initial state. So similarly, we need to identify what is the precondition and what would be the post condition of the system. Then we say, okay, that what is the normal flow of this use case, and we always write it in the numbered form. So say 1, 2, 3, 4, 5, and we start writing, okay, these are the normal events, and this is how the user is going to interact with the system. But an important thing is that there might be alternates. So for example, when a user selects a particular language, And now there are two possibilities. Default option can be that the machine is going to display all the information in English, but if somebody selects Urdu, then that is an alternate flow. So for example, this step 3 was actually asking the user to select a particular language. So we might have an alternate flow here, and we need to express that with the number 3a. So 3 is actually saying that this is related to this original normal flow 3, but because this is alternate, so we are expressing that, okay, it's 3a. Okay, but that's not the only thing that we have in a use case text. Another thing that can occur is that there can be certain exceptions in a use case. And exceptions mean that, for example, when the user was trying to enter the PIN number, so there might be a case that the PIN number was incorrect. So when the PIN number was incorrect, then the use case or the machine should behave in a totally different fashion. So what we do is we identify the normal flows, and then we think of all these normal flows, that what are the possible exceptions, or what were the things that can go wrong, or what are the things that can happen, or how can my system behave in a different fashion depending on what the user does. Okay, and that is why use case text is really important, that we identify these actions. And now you can actually see that this analysis part has really kicked in, and we are gaining more understanding about the product. Another interesting thing that we discussed during our discussion on use case text, and that was that at times during this analysis, and although we talked about that, we mostly try to identify the functionality and we try to understand the function of our system, but at times we also identify that when a user would be waiting for a certain transaction, and if the banking system is not responding, for example, then we need to actually figure out that how long should the machine wait for the banking system to respond. Now that is a requirement, but it's not a functional requirement. It's related to behavior of the system, and it's maybe a non-functional or a performance requirement that for each transaction machine should wait for maybe 60 seconds, and if there is no response from the banking system, then the machine should say that your transaction has timed out and the banking system is not responding, or whatever the message you select. But when we are thinking about this particular scenario, then we also mention these things, and they are expressed in the form of, so we can have another section in the use case text which would be called special requirements. So we can also write these things in it as well. So you can see that this use case modeling, this use case text, or using use case text in scenario based modeling is really helpful for analysis. And next up in the scenario based modeling, we talked about the activity diagram, and as we said that when we make a use case, we only think about the normal flow of events, and during the use case text we said no, there can be alternate flows and there can be exceptions. So what we do in an activity diagram, we know that where our sequence is starting from, so we know the starting state, and we say, okay, the first thing that a user is going to do is, the first activity that a user is going to do is maybe insert the card. So the next thing the user is going to do is enter PIN number. And we know that in the normal flow we have assumed that the PIN number is correct. So if the PIN number is correct, then user is going to select language. But we have seen in the use case text that there can be an exception, that an exception can occur here, and there is a possibility that the PIN number is incorrect. And when we are saying that, so there would be a different action would happen here, and when the PIN number is incorrect, you will ask the user to maybe enter the PIN number again. Okay, so what an activity diagram does is it tells us we have identified those alternate flows and we have identified those exceptions during use case text, and now what we are trying to do, we are trying to visualize that in what order these things would happen, and how, and in what order my system is going to behave in this fashion. And so again, this is from user's point of view. So what an activity diagram does is, the way we talked about during analysis, an activity diagram is useful in whenever there are alternate actions or exceptions in a use case, or whenever there are different scenarios that can occur. We make an activity diagram, and it shows how these things would happen when a user is going to interact with the system. And the next thing that we talked about within this scenario-based modeling with activity diagrams was swim lane diagrams, and we said that swim lane diagrams is exactly the same diagram as an activity diagram, but we said that because there may be multiple actors involved in a particular interaction or in a particular scenario, so we want to identify that which activities would be performed by which actor. So for example, we say that each scenario kicks in with a primary actor, so there would be always an initiator. But there is always the banking system there as well. So what we do is that we try to draw this diagram in a fashion where we distribute the activities, so all the activities related to the bank client would be written here, and all the activities which belong to the banking system or the system, they would be written here. So what we are doing is we are trying, because we said that this is the scenario based modeling, it revolves around the user, and we are trying to gain understanding about the system from the user's point of view. So what we are saying is essentially that we want to know that when we make this swim lane diagram, that which actor is responsible for these actions, and which behavior or what kind of output or what kind of input we expect from these different actors. So this is what it's about. So that was scenario based modeling that we talked about. Next up, in object oriented approach, we talked about class modeling, and within class modeling, the first thing that we talked about was class diagrams. And within class diagrams, we said that what we do is and that is very interesting, because what we do is we try to identify our information domain classes. Now some classes, as an experienced requirement analyst, when we gather those scenarios and when we perform our initial analysis, we might be able to identify few things very quickly, and we say, okay, these would be maybe the classes in my system. But it's actually more systematic, or this process needs to be more systematic than just through experience. So what we talked about is that we have all those scenarios, and from those scenarios, what we try to do a grammatical parse. Okay, so let's say we have this big user story or scenario that we have gathered in elicitation. What we do is we do a grammatical parse, and through that grammatical parse we identify all the nouns and noun clauses. So we say that all these noun and noun clauses, they are my potential classes. But again, in the text that you have, there might be, if it's a big system, you might end up with hundreds of these potential classes. But in reality, you may not make all of them your actual classes or actual information domain classes in your system. So we need a mechanism to actually filter from this list of potential classes to the classes that I would actually be making in my system. So we said that there is always a selection criteria that we have in place. So we have a selection criteria, and based on that selection criteria, we say we filter these information domain classes. Okay, so we are going to select few classes from those big pool of potential classes, and so I get my final classes. So but now at this stage, all I have done as an analyst, I have gained an understanding about the information domain, and that too by identifying different information domain classes. So if you guys remember a class diagram, then a class diagram has multiple sections. So usually the class name is written here. So maybe at this stage we just have this information and about maybe 5-6 classes of the system. But there are other things in a class, and these are attributes of a class, and we also have operations of a class. So the next thing we do is that, as we said, that we identified lots of potential classes, and from those potential classes we have taken some to be our final classes, and that's what we have at this stage. So the nouns which we rejected as potential classes, we are going to look at them closely, and we will try to relate them to different classes. So we'll see, okay, if that's a noun, and it seems to be that it is very close to this particular class. For example, in the examples that we did, we said that the system is a class. Okay, and within the system we have a master password. So master password was also a noun, but we said, okay, we need to, this seems to be close to this class system. It does not seem to be close to the class sensor. So there were multiple classes that we identified in our example. For example, one of the class was sensor, another class was system. So for example, a potential class that we identified during our earlier grammatical parse was this master password. Now what we will try to do is we'll try to look at all the classes and we say, okay, this master password, it seems to be close to which class? The sensor class or the system class? So it seems to be close to the system class. So we are going to say, okay, this is going to be one of the attributes of the system class. So that's how we identify the attributes of a particular class. But we still have not understood that how my class is going to behave. Okay, so we have developed an understanding about information domain by identifying the information domain classes and by identifying the attributes. But the behavior of the class is kind of complete when we are not complete, but we gain more understanding about it when we identify different operations, because the values of the attributes of a class are going to change when we apply these attributes on instances of the classes. So the next thing is, how do we identify these operations? And for that we do through this grammatical parse. Another output is all the verbs or the action words, and those action words, whatever pool of verbs that we have gathered, what we try to do is we again try to relate them to these different classes. For example, displaying sensor information or sending sensor information, or monitors, for example. So let's say monitors was a word that we identified. So now we need to know that, okay, this word monitor, whether it belongs to my system class or the sensor class. Okay, now my system class is actually going to monitor the sensors. Okay, so I will have maybe an operation here which is going to say that it is going to monitor the sensors. So again I am saying that that's another operation. So I develop more understanding about the system by identifying these operations, attributes and classes. But one thing that we haven't done so far is that how and as we know from our knowledge about these class diagrams, that a class diagram is not just a bunch of classes, it's actually how these classes are going to interact with each other, and that's how a system is made. So another thing we talked about during class modeling was CRC modeling, which we call class responsibility collaborator modeling. Okay, and what we try to do in these CRC cards is that we said that in a CRC card, it's basically divided into three main sections. Here we write the class name, and here we write the responsibilities of this class, and here we write the collaborators of this class. And this is a very interesting and very systematic way of knowing about behavior of the system, because it gives us the basic associations, or it tells us that whether this class is going to need another class to perform a certain responsibility. So it's very simple. What we try to do is we know, by now we know the responsibilities of a class. Okay, and we look at these responsibilities. For example, the monitoring sensors was the responsibility of the system class, but system class cannot do it without collaborating with the sensor class. So for example, let's say this class was system, and one of the responsibilities of this class was monitoring, but it cannot perform this monitoring responsibility without actually collaborating with the sensor class. So we know, okay, that this was the system class, it needs to have an association with this sensor class. So we are not going, and we did not go into the details of what are the different types of associations, and I'm sure that you guys are familiar with that. There are multiple kinds of associations that can be in a class diagram, but as a requirement analyst, all we want to know is about the behavior of the system. So for example, we knew that when my system is in a monitoring state, there are lots of things that are going to change within the instance of that system class, but this monitoring is not complete without getting some information from the sensor class. So now I get, okay, that when we are making a system, or if there is a requirement, we need to actually know, okay, that when we monitor, we need to actually look at all these different sensors, and we need to actually process this information in another fashion so that we can actually make some meaning or take some meaning out of it. Because sensors or these hardware, they are intelligent only to a certain extent. The more intelligence is actually more the results of the values that we get from these sensors. We make it more intelligent through our system, because we are saying that if the sensor output is beyond a certain acceptable range, we are going to sound multiple kind of alarms and these kind of things. So we know more about the behavior and functionality of the product when we do this CRC modeling. And next thing that we talked about was within the object-oriented approach was this behavioral modeling. And within as the name suggests that, this is actually targeted towards understanding the behavior of the system. Okay. And when we talk about behavior of the system, and because this is object-oriented approach, so we know the key concept around which this whole modeling revolves are basically classes. So what we are saying is that there are two things that we discussed in behavioral modeling. One was state diagram, and the other one was the system sequence diagram. So what is a state diagram? A state diagram actually tells us the behavior of a particular class. So if we are interested, so for example, we have 5 information domain classes that we have finally selected. Now, if I want to know how this class is going to jump between different states, I will start making these state diagrams. So what I would do is that, and what is a state? We also talked about it, that a state is the values of the attributes of a certain class. So for example, we have an instance of a class, and depending on the values of its attributes, we are going to say that a class is going to, or this instance is going to jump between different states. So what we do is we say, okay, that this is my current state, and based on a certain operation, because these values of my attributes are going to change, I will be in a new state. So what I do here is that I try to specifically talk about behavior of my particular class. Now that might not be it, because I also want to know that when my system behaves in this fashion, how the whole system behaves, because we have talked about that there are certain responsibilities which a class is not going to do on its own. And if you guys remember, for example, when we are monitoring, then system is going to behave in a certain fashion, but because there was an association here with the system class, so there would be some event which would be sent to this sensor class. Okay. So for that purpose, what we draw is we make sequence diagrams, and that's why these are called system sequence diagrams, because based on an initial event or based on an initial action by the user, I know my system is going to behave in a certain fashion. So what I have in a system sequence diagram is I have all the classes which are going to be involved in this particular scenario, and there is this initiator object which is going to initiate a particular sequence. And then what I do is that based on this initial set, I say, okay, how my class is going to deal with it. And because I know that my classes have associations with other classes, so in order to maybe complete this particular functionality, the class sends an event to another class. And based on its response, it basically completes its functionality. So to understand the behavior of a particular class, we make state diagrams. But because these classes, they have associations with other classes, we need these system sequence diagrams to understand that when an interaction is going to occur, or when an event is going to occur, what would be the behavior of my complete system. So that was object-oriented approach, and we can see that when we are performing analysis through this object-oriented approach, what we are actually doing is that we have gained, remember those 3 things that we are interested in. We were interested in information domain, we were interested in the behavior of the system, we were interested in functionality of the system. So we can see that we have understood the behavior and functionality of the system from the user's point of view when we did scenario-based modeling. We have identified our information domain classes, we have identified the attributes of these classes, and we have gained some understanding about the information domain. Okay. And we also identified some attributes or some operations of these classes, and by identifying those operations, we gained some knowledge that what would be the functionality that my system is going to need, and what will be the behavior of my system. But behavioral understanding was not complete yet, because we said that a class might have multiple attributes, and there might be multiple operations, and based on those operations, a class can go into different states. So we said, okay, let's do behavioral modeling to understand the behavior of a particular class. But because these classes talk to each other, we said, okay, whenever a class is going to change its state, the system state would change. And for that, we talked about the system sequence diagram, which gives an understanding about behavior of the overall system. So that was the object-oriented approach of analysis. Next up, we talked about the structured approach. And within structured approach, as I recapped in today's, when we started today's lecture, that we talked about flow-oriented modeling. And we said that when we draw these DFDs, then through these DFDs we know about the information domain, we know about behavior, and we know about the functionality. And how do we do all these things? Because we identified data, and because data is central to this data flow diagrams, because we are modeling the flow of data through our system, and we understand the behavior of our system through by identifying these operations or decomposing our main process or main system into, you know, those small processes and those sub processes. And this DFD, and I said earlier as well that when we do this object-oriented analysis, then there are a whole bunch of, there are lots of kind of modeling that is available to us, and each kind of modeling is targeted to gain certain kind of understanding. Some are targeted to gain understanding from user's perspective, some are targeted just to understand the behavior of the product, some are targeted to just to gain understanding about the information domain. Whereas when we are making DFDs, that's why I said making a DFD is more complex, because it has it all and you don't want to miss anything. So right amount of detail is very important when we are making these data flow diagrams, because when we draw these data flow diagrams, we try to understand behavior, functionality, and information domain all in one. So this is what we have talked about in elaboration, and that is how we actually perform elaboration. So before we conclude our elaboration, this is a slide that we have already seen, but I thought it's important that we conclude this discussion on the elaboration process with this slide, that there are certain things to remember when we are doing analysis. The first thing is the analysis model should focus on requirements that are visible within the problem or business domain. So that is very important, that you restrict yourself to the problem at hand. And that is why when we say the boundary of the system, the scope of the system, you know, that is very important. So anything that is outside, we should not think about it. Okay? And the level of abstraction should be relatively high. Again, we are not actually designing the product. And that's why, you know, when you guys must have seen that I skipped lots of details about those diagrams, because I don't want to delve into that detail, because I am at the analysis phase. And I just want to gain understanding about the product, because I want to get rid of all those problematical requirements. So next thing that we need to remember when we're doing analysis is that each element of the analysis model should add to an overall understanding of the software requirements and provide insight into the following. And these things are really important, which we have emphasized again and again, that this is what I want: information domain, function, and behavior of the system. So that is central to this whole analysis process or elaboration process. The model should delay the consideration of infrastructure and other non-functional models until the design phase. So we should not worry about reliability, performance, what kind of hardware we need to run it on, what kind of infrastructure we have. So all these things, they would come in later when we are actually designing the system. Our focus should be just on the requirements. The model should minimize coupling throughout the system, and this is something which we take into design as well. When you talk about design, then a good design is where coupling is minimum. Okay, and so a good design is where you have lots of cohesion and minimum coupling. So that's what we talk about. We try to reduce the level of interaction between, for example, if we have lots of classes, an ideal class diagram would be that if we have lesser interaction between those classes. And the next thing is the model should provide value to all stakeholders. So whatever this modeling is you know, we will see in a bit that the next process following elaboration is negotiation. And so all the effort that we have put into analysis, it will be of no use if, you know, it does not give any value to the stakeholders. Because we said that, you know, DFDs, for example, they are a logical view of the system, and this is an analyst's logical view of the system. But we take it to the client and we say, okay, this is how we think, you know, these things are going to happen. So do you agree with it? You know, these are the problems that we have identified when we made this data flow diagram. And so it should add value to the stakeholders. The model should be kept as simple as can be. So simplicity is really important, and that's why we said that abstraction level is normally high. So just remember, whenever you are doing analysis, that your focus should be just on the problem at hand. You should focus on the requirement. You should focus on functionality. Do not delve into other details. So this is really important. So I just like this diagram because it's actually give us a perspective, you know, from the point of view of this whole discussion on requirement engineering, and from the perspective of our course, that where we are at the stage. So we have done inception, we have talked about elicitation, and we have done elaboration. And as you can see, you know, that there is a reason why we have these processes written in this fashion, that inception leads to elicitation, because what we gather from inception, it helps us in eliciting requirements from the clients. Similarly, elicitation leads us into analysis, because we want to know more about the product. But when we have done analysis, we have understood that there are lots of problems with what we gathered, and so for that we need this particular process, which is negotiation. So from today's lecture, we are going to talk about negotiation and what are the different things in negotiation, and what are the different activities involved when we say we negotiate the requirements. So negotiation as a process, and again, because I am I practice a lot this process improvement, and I am part of it as an academic as well, and as a practitioner as well. So I like to talk about every process in this fashion, that let's say negotiation is a process. Now, before we delve into the details of negotiation, that what are the different steps or what are the different stages of this negotiation process, I just want to see that we actually understand that what are the inputs to this negotiation process. When we are at the stage of negotiating with the client, what do we have here? So we have a bunch of requirements that we have identified, as problematical through our analysis. Okay, so these are the requirements that we have identified, and now all we want to know is, through this negotiation process, our output that we expect from this negotiation process is consensus. So we want to develop a consensus with the client that these were the problems. So as an input, we send all those problematical things that we have identified to this negotiation process, and let negotiation process deal with the client and produce an output which is of consensus. And we say, okay, these are the final things, and let's move on to the next process, which is going to be specification. So negotiation is all about dealing with these problematical requirements, and as you can see that negotiation is an art. You would have seen from your experience, for example, some of your friends, when they go to different shops, they negotiate well, because this is something which is very common in Pakistan, that you go for shopping and you start negotiating. But others, they just don't negotiate, because they don't know how to do it, and whatever the shopkeeper asks, they would just pay it, and they are happy, the shopkeeper is happy. But some people actually love negotiation, so they are good at it. That's why at times we say that negotiation is an art. So it's an art which you obviously learn from practice, and it's an art that some people are more good at. But as an analyst, because we are talking about requirement engineering, so there are certain things that we have identified, that how you go about this negotiation as a requirement analyst. Okay, so what is this requirements negotiation? So disagreements about requirements are inevitable when a system has many stakeholders, and as we said that we are dealing with people, and when we say we are dealing with lots of different people, different kinds of people coming from different backgrounds, people using the system in different ways, then there are multiple viewpoints. So conflicts are inevitable. But these conflicts are not failures. They just represent that okay, different systems see this particular functionality in a totally different fashion. How we satisfy all these guys? So this is what it's about. So requirement negotiation is the process of discussing requirement conflicts and reaching a compromise that all stakeholders can agree to. In planning a requirement engineering process, it is important to leave enough time for negotiation. So this is important. If we look back at this particular diagram and we say, okay, that this is how we plan our requirement management engineering to go through, that we will start with inception, elicitation. So we should keep enough time for this negotiation, because this is really important, and we will need some time to actually negotiate with our client. So we may start specification at the same time, but we need actually some time for negotiation. We need to talk to the people, okay, and we need to satisfy them, because in the end they have to accept the product, and we will not be able to validate requirements if we did not negotiate and finalized all those conflicting requirements properly. So this is very important to the following processes of requirement engineering. So finding an acceptable compromise can be time consuming, so that's why we need to set aside some time during negotiation. So what does a software or requirements engineer or a requirement analyst does during negotiation? So during negotiation, the software engineer reconciles the conflicts between what the customer wants and what can be achieved given limited business resources. So remember always that there is in project management we say that there are three constraints to a system that you are going to make, or there is a project that you are going to do. One is the scope of the system, the other is the time and the cost. Some people say that there are four constraints and they put quality into it, but others believe that because quality should be everywhere, so they just say that it's going to be there. So merely some people say that these are the more commonly people say that there are three constraints, and these are referred to as triple constraints. So remember that when we are talking about this requirement engineering process, then it actually falls into this discussion of scope. So we are gaining more understanding about the scope, we are trying to limit the scope, or we're trying to give boundaries, identify the boundaries of the system. So we know that we have to achieve this scope in a certain amount of time, and there is only so much money that we can spend it. So we have limited resources, so we need to think about these things, and we need to come up with a scope which everybody is happy with, all the stakeholders are satisfied. So that is what this negotiation is about, that trying to strike a balance between your resources and trying to and what you have to do. So what we do is requirements are ranked by the customers, users and the stakeholders. So one very important activity or one very important task of negotiation is requirement prioritization, and we are going to talk about it in lots of detail, but very simply what we do is that, as it's written here, that there are different ways of ranking requirements, but very simply let's say that there are three different stakeholders, and we have identified lots of these requirements. We say, okay, let's start ranking these requirements, and if there are 10 requirements, then different people might come up with different rankings. So we need to come up with one consolidated ranking which would be used to resolve those conflicts and which would be used during the negotiation. So what we will do is that we will pick the most important requirements and we try to resolve the problems with them. So the next thing is that the risk associated with each requirement are identified and analyzed. So the next step is risk analysis. So we prioritize requirement, we identify risks in the requirements, and the next thing that we do is that we try to guesstimate. So we try to make rough guesses of the development effort, and we try to understand the impact of each requirement on the project cost and delivery time. So what we have by now is that we have a list of requirements which is prioritized. We know the risks of each requirement, and we also know the impact each requirement it's going to have on the cost and time. And then what we do is that then actually we begin this negotiation, and this negotiation is an iterative process. So what we do is that using an iterative approach, these requirements are combined, eliminated or modified so that each party achieves some measure of satisfaction. So negotiation, so we know by now that negotiation is an iterative process. So we prioritize requirements, we identify risks, we try to evaluate each requirement and look at the impact of each requirement on our these two limited resources, which we have said is time and cost, and we say, okay, let's combine some requirements, let's delete some requirements, and let's try to resolve the conflicts in these requirements so we can complete what we want to do within the limited resources that we have. So that is it from our discussion in today's lecture. So let's quickly summarize what we have done and what we talked about today. So in today's lecture, we started off with our with summarizing the elaboration process, because it was I think one of the most detailed process of requirements engineering. So we talked about it in detail, that how we developed an understanding about the system, how we developed we got to know more about information domain, behavior and functionality of the system. And then we moved our discussion to the negotiation process, and we said that negotiation is really important. And so as a process, we can see that during negotiation there are lots of things which are happening. So we have said that when we are actually negotiating, so the first thing that we do in negotiation is we prioritize requirements. So that is the first thing, or the first step, which is prioritization. And then what we do is we try to identify risks of each of these prioritized requirements. So let's say we have a list of 1, 2, 3, 4, 5, 6, and this is the ranked requirements with the most important at the top. So the first requirement is of the highest priority, then number 2, number 3, and number 4. So we say, okay, these are the risks associated with requirement 1 and risk associated with requirement 2. So we list all these things. And the next thing that we try to do is we try to do an impact analysis. Then we try to do that, okay, what if these risks occur, what is going to happen on time and cost. So impact analysis is always in terms of those limited resources, and as we said, remember those triple constraint diagram, that we have limited resources in terms of time and cost. So we look at the impact of each requirement on these resources, and then we actually start an iterative process, and this iterative process is about getting this consensus that we desire, and which is the main output of this negotiation process. And this ends only when we have a final set of requirements where all the stakeholders are satisfied. So we are going to continue our discussion on the negotiation process in our next lecture. We are going to talk in detail about prioritization. We'll look at a couple of techniques which are proposed in literature lately about prioritization. And that's it from today's lecture. Take care and Allah Hafiz.